Good morning, students. In this class, we are discussing about the crankshaft. In the last class, we have discussed about the design process of the cylinders. Once we will revise the design process of the cylinder and different problems we have discussed. In the design process of connecting rod, we have discussed about the different process. First, we have discussed about the cross section of the connecting rod. Next, we have discussed about in I-axis and I-Y direction means at the movement of inertia in X direction and Y direction. After that, we have discussed about the dimensions of piston pin at small end. Once we have recollected the connecting rod in the IC engines, the connecting rod is attached to the piston pin at small end and also the crank pin at the big end. Okay. Next, we have discussed about the size of the bolt at the pick and cap, thickness of the pick and cap, and also the stresses developed in the connecting rod. In this class, we are discussing about the crankshaft. What is meant by crankshaft? It is a shaft which transmits the power developed by the engine to the various parts of the vehicle. It is a link between the input and output of the vehicle. Without crankshaft, our vehicle won't even move an inch to our engine will be running. What is the mean by crankshaft? Crankshaft is nothing but it transmits the power developed by the engine. First, you imagine about the IC engines. In the IC engines, in the starting class, we had discussed what are the parts of the IC engines. First one, it is called as cylinder. Next, cylinder head. After that, the piston. After that, connecting rod. And next, crankshaft. These are the main parts of an IC engine, which they will transmit from one part to the another various parts of the engine. Okay. What the piston will do? Piston is nothing but the power will be developed from the cylinder. Okay, connecting rod is nothing but the power will be transmitted to the crankshaft. Okay, what will be what is the work of the crankshaft? The work of the crankshaft is nothing but it is a shaft which transmits the power developed to the engine. If you it transmits throughout the engine, due to the power various parts of the vehicle. Okay, it is nothing but the link between the input and output of the vehicle. And next, without of the crankshaft, the vehicle won't even move an inch through our engine will be running. This is the different types of the different parts of the IC engines. Okay, first one, the main part of the IC engine is nothing but cylinder. Cylinder next, after that, cylinder head. Cylinder head after one piston. Piston is connected to the connecting rod. Connecting rod is connected to the crankshaft. These are the main parts which are developed in the IC engine. Okay. And next in this crankshaft only there are different parts. It is nothing but a crank pin. Okay, crank pin and also web. Next flange. These are the different parts of the crankshaft. Okay. Next, the types of crankshaft is nothing but it will be in the same plane or it will be the cross plane. See, if you see in this diagram, this is the where the power will be transmitted. Okay, this is the shaft. This is the shaft. These are the four parts which will be moving the IC engines. Already you know the various parts of the IC engines. First one is the compression, a working exhaust, and the working stroke. Okay, these are the four parts of the IC engines. It is nothing but the same plane and also the cross plane. In the same plane, the shaft will be lying on the crankshaft. In the cross plane also, the cross plane, the shaft will be lie on this different the process of the planes. Okay, the types of crankshaft is nothing but single through crankshaft, double through crankshaft, four through crankshaft, and the six through crankshaft. Okay, next one, functions of crankshaft. Functions of crankshaft is nothing but it changes the reciprocating motion of piston into rotary motion to the driver. Just imagine the working process. It will go to and fro motion. Okay, to and fro motion only the reciprocating motion of piston. It changes into the rotary motion of the drive wheel. Next, constructed of chrome, nickel, molybdenum, and steel. The propeller is mounted in front of the crankshaft using the spline, taper, or flange part. Crankshaft rotates within the crankcase and is supported by and is supported by main bearing journals. Okay, this is the function of the crankshaft. Okay, this is the function of the crankshaft. The function of crankshaft is nothing but it changes reciprocating motion of piston into rotary motion to drive propeller. Next, constructed of chrome, nickel, molybdenum, and steel. The propeller is mounted in front of the crankshaft using a spline or flange. Crankshaft rotates within the crankcase and is supported by main bearing journals. See, this is the crankshaft. If you see in this diagram, this is the shaft where it produces the different types of parts. Different type means four process will be done. Okay, from the inlet and exhaust valve. Okay, in this shaft only there are mounted in different parts. First one is called it as crank nose. This part is now called it as crank nose for pulley and vibration damper mounting. Main bearing journal. Okay, these are fixed with the depend upon the bearings. Next one, mount for crankshaft dry sprocket. Main journal oil way to lubricant crank pin. Where the crankshaft is there, in that crankshaft only the crank pin and also the web flange will also be developed in that crankshaft only. Okay, this is the web. Web is nothing but where the four different types of parts will be rotated. That part is called it as web. This is the main journal. Next, crank pin and hole crank pin journals, and also the counterweight with the help of the flywheel. Flywheel is nothing but where the power will be transmitted with high efficiency with the help of the flange. It is called it as a flywheel. These are the parts of the crankshaft. Okay, next, this is the web part. What is meant by web? Already we had discussed in the journal bearings also. What is meant by web? The web is nothing but the portion of a crank between the crank pin and the shaft or between adjacent crank pins called as crank arm or crank throat. Okay. Next, crank journals. Web is nothing but the main part of the shaft where the support system of the shaft is called it as a web. It depends upon the crank and crank pin. Okay, crank journals. In a reciprocating motion, the crank is also known as crank journals, or the journals of the big end bearings at the end of the connecting rod opposite to the piston. Okay, if the engine has a crankshaft, then the crank pins are the journals of the off-center bearings of the crankshaft. In a beam engine, the single crank pin is mounted on the flywheel. In the steam locomotive, the crank pins are often mounted directly on the driving wheels. Okay, in a reciprocating engine, the crank pins, also known as crank journals, are the journals of the big end bearings, and also the at the end of what is meant by big end bearing. Big end bearing is connected to the crankshaft, and the small end bearing is connected to the piston pin. Okay, if the engine has a crankshaft, then the crank pins are the journals of the off center bearings of the crankshaft. In a beam engine, the single crank pin is mounted on the flywheel, and also the locomotive engine, the crank pins are often mounted directly on the driving wheels. What is meant by main bearings? Main bearings is nothing but in a piston engine, the main bearings are the bearing on which the crankshaft rotates, usually plain or journal bearings. Okay, the bearings hold the crankshaft in place and prevent the forces created by the piston and transmitted to the crankshaft by the connecting rods. It is called it as main bearings. Okay, this is the main bearings where it is called as main bearings is nothing but the where the shaft. This is the shaft mounted. Okay, that the shaft mounted where the bearings will be fixed. It is called as main bearings. Okay, this is the shaft and this is the shaft. The shaft where is supported to the bearings is called it as main bearings. See, this is the part which we are taken in the IC engines. This is called the piston. Okay, piston. Piston is directly connected to the connecting rod, and the connecting rod is connected to the crankshaft. Okay, and there gudgeon pin, connecting rod, crank pin, top ring, bottom ring, skirt, little end, big end, and crankshaft. These are the parts which are developed in the IC engines. Okay. This is made by crankshaft. Okay, have you understood? Crankshaft is nothing but which transmits the power developed by the engine to the various parts of the vehicle. It is a link between the input and output of the vehicle. Without crankshaft, our vehicle won't even move an inch through our engine will be running. Types of crankshaft is nothing but same plane and cross plane. Okay, types of crankshaft is nothing but single throw crankshaft, double throw, four throw, six throw. Function of crankshaft. It changes reciprocating motion of piston into rotary motion constructed to the developed area consisted of chrome, nickel, molybdenum, and steel. The propeller is mounted the front of crankshaft using a spline, taper, or flange. Crankshaft rotates within the crankcase and is supported by main journal bearings. Okay, next parts of the crankshaft. These are the main parts of the crankshaft. One is crank journals, crank pin, main journals, and flywheel. These are the main parts of the crankshaft. Okay, next web. The portion of a crank between the crank pin and the shaft or between adjacent crankpins is called as web or crank arm. Okay, crank journals. In a reciprocating engine, the crank pins are also known as crank journals or the journals of the big end bearings at the ends of the connecting rod. These are the main bearings. Next one. Next one we have discussed about the overhanging crankshaft. First, what is meant by overhanging crankshaft? Over crankshaft will have two different types of crankshafts. One is center crankshaft, another one is overhanging crankshaft. Overhanging is nothing but where the crankshaft is developed. See, this is the crankshaft. Okay, this is the crankshaft. It depends upon the center. The connecting rod is applied to the center. It is called it as center crankshaft. Otherwise, the connecting rod, the load is fixed through the overside of the crankshaft. It is called it as means side of the crankshaft. It is called it as overhang crankshaft or overhanging crankshaft. Okay, the overhanging crankshaft is subjected to different types of stresses developed in the crankshaft. It is called it as a bending stress, direct compressive stress, shear stress, bending stress due to tangential force, bending stress due to radial force, and compressive force. Okay. While designing an overhanging crankshaft, the following three steps are considered. One, when the crank is at dead center. Next, when the crank is at an angle of maximum twisting movement. Okay. Bending stress. Bending stress already we know direct compressive stress means different types of stresses developed on the crankshaft when the load is applied. Okay, that is nothing but bending, direct compressive, shear, and also bending stress due to tangential force, radial force, and compressive stress. Okay, while designing an overhanging crankshaft, the following steps are considered. One is when the crank is at dead center. Next, when the crank is at an angle maximum twisting moment. See, this is the difference between the center crankshaft and also the side crankshaft. See, side crankshaft is nothing but this is the shaft. This is the shaft. Side crankshaft is nothing but the shaft developed on the load is side by side. Okay. Here by the center crankshaft, the crankshaft will be the load will be applied at the center. Only the center part is called it as a center crankshaft. Okay, next design procedure of center crankshaft is nothing but the procedure adopted for designing a crankshaft is as follows. First one, initially the magnitude of various loads on the crankshaft should be determined. Second one, the distance between the support and the position with respect to the load is determined. For safety and feasibility purpose, consider the shaft to be supported to the center of the bearing. Ensure the thickness of the disc to be 0.2 D to 0.6 ds, where ds is the shaft diameter or 0.22 D to 0.32 D, where D is the bore of cylinder. Next, fourth one, calculate the distances between the supports. Determine the main dimensions of the crankshaft by issue logic built-in and clear. pin. This is the design procedure of the crankshaft. The procedure adopted for designing a crankshaft is as follows. First one is nothing but initially the magnitude of the resistance on the crankshaft should be determined. The distance between the support and the position with respect to the lower is determined. కొద్దిసేపు అది ఆపచ్చు కదా. For safety and simplicity purpose, consider the shaft to be supported at the center of the bearings. Issue thickness of the bearing. కొద్దిసేపు ఆపచ్చుగా ఉంది. which 0.4 ds to 0.6 ds. The ds is the shaft diameter or 0.22 d to 0.32 d. Where d is the bore of the cylinder. Calculate the distances between the supports. Finally, determine the main dimensions of the crankshaft by showing allowable bending and shear stress. Crank and crank arm. Next one is called it as crank and crank arm. The simple form of crank is shown in the figure. It consists of an arm enlarged into each end. The larger force of the pressed onto the shaft, and the small boss force the pen, which is pressed into place and riveted or fastened by a nut. Empirical proportions are given in a figure in terms of the diameter of the shaft ds and the diameter of the crank pin. The crank pin is usually designed as a journal and then checked for strength. Let P is equal to maximum force on the pin. P is equal to allowable bearing pressure in kg per centimeter square. L, length of the crank pin, diameter of the crank pin. A simple form of crank. First one. This is nothing but where the crankshaft is projected. First, this is the crank arm. First, what is meant by crank arm? Crank arm is nothing but where the crankshaft, the side portion of the crankshaft is called it as the crank arm. A simple form of crank is shown in the figure. It consists of an arm enlarged into a boss at each end. The larger boss is pressed onto the shaft, and the small hole boss holds the pin, which is pressed into place and riveted or fastened by the nut. Okay. Let P is equal to maximum force on pin in kg, allowable bearing pressure in kg per centimeter square. Generally, it ranges from 85 to 112. L, length of crank pin, D, diameter of crank pin. The ratio L by D varies from 0.8 mm to the for the fast method of the length. Usually, this ratio is unity or a little more. P is equal to PDL. The bending moment turns the pin for an evenly distributed load, and P becomes PL by 2. But actually, the pressure maximum not evenly distributed the bending moment when as a P into L. See, this is the different types of the shaft. The shaft is holded on the crankshaft. Okay. Next, where the length of the different types of crankshaft is nothing but means the side portion of the crankshaft is 0.5 ds and also to the 1.4 ds. Okay, the crank arm is also used to check the strength, and the cantilever beam of length are fixed at larger end of the supporting load. Okay, next, another part of the crank which is usually used it involves marine engines and IC engines as shown in the figure. The empirical relationship are also based on the approximation and use same results for ordinary conditions. Okay, the arbitrary positions of the crank when it is turned through an angle theta. Let F not be the force or the axial thrust in the connecting rod, which resolves itself into a tangential turning force F and the radial force Fr along the arm. F is equal to F naught sin alpha plus theta, as gamma is equal to 90 degrees minus alpha minus theta. F is equal to F naught cos alpha plus theta. This is the arm. This is the arm positions of which we will take used by the shaft position. Next, in the dead center position, Fr is maximum and is equal to F naught, but F is equal to 0 for x plus theta is equal to 90 degrees. That is when crank arm and connecting rod are at right angles, F is maximum and equal to the Fe, and Fr is equal to 0. Next, if the force Fe is slightly varying, then the force acting on the pin in any position is same, but the force on the arm is very different. Okay. For instance, on the section AA, the compressive stress on the bending moment of different positions of the rectangular cross sections of the arm when the crank is at 90 degrees position, the bending moment of the section is F naught into Z. Twisting moment is F naught into X, and also the shear stress is formed. Okay, next topic. Different stresses induced in the crank pin. The different stresses induced in the crank pin are a bending stress and also the torsional shear stress. Torsional stress, the bending stress is nothing but the bending stress at any section is given by sigma b is equal to mb into y by I, where mb is nothing but applied bending moment, I is nothing but moment of inertia of the cross section about neutral axis. When the beam is subjected to bending moment, then the distribution of stresses can be analyzed by bending a thick weather bend. Okay, means the bending stress will be developed in the connecting rod. The bending stress induced in compressive in nature above the neutral plane and is tensile below the neutral and compression. Okay, thus the bending stresses is maximum at the farthest fiber from the neutral axis. Next, a torsional shear stress. Torsional shear stress is nothing but the stress induced under torsion is called torsional shear stress. A torsion is said to occur when a machine member is subjected to equal and opposite couples acting in parallel planes. When a shaft is subjected to torque T, then the shear stress induced will be of the magnitude varying from 0 at the center to maximum at the outer surface of the shaft. Shear stress at the outer surface is given by tau max is equal to 16 d by pi d cube. 16 d means with respect to the diameters also. We can take it as a tau max is equal to 16 d naught by pi d power d naught by 4 minus d I by 4. Do is nothing but outer diameter, di is nothing but inner diameter. Okay, where d naught is nothing but our outer diameter of the shaft, di is nothing but inner diameter of the shaft, and t is nothing but torque applied of the shaft. Okay, these are the different stresses induced in the different types of stresses induced in the crankshaft. Okay, crankshaft. In this class, we have discussed about different types of crankshaft and what are the parts involved in the crankshaft. First, what is mean the crankshaft? Crankshaft is nothing but it is a shaft which transmits the power developed by the engine to the various parts of the vehicle. Okay, it is a link between the input and output of the vehicle. Without crankshaft, our vehicle won't even move an inch through our engine will be running. Next, types of crankshaft. Types of crankshaft is nothing but same plane and cross plane. And also the different types is nothing but single through, double through, four through, and six through crankshaft. Okay, function of crankshaft. Function of crankshaft is nothing but it changes reciprocating motion of the piston into rotary motion to drive the propellers. Okay, constructed of chrome, nickel, molybdenum, and steel. The propeller is mounted at the front of crankshaft using a spline taper or flange. Crankshaft rotates within the crankcase and is supported by main journal bearings. Okay, this is the parts of the crankshaft which we are seeing in this image. First, it is called it as crank nose and the pulley of different vibrations. Next, mounted for crankshaft, journal bearings. counterweight, whip, crankpin, main journals, crankpin oil hole, counterweights, and also the flywheel mounted on the image. Web. Web is nothing but the portion of the crank between the crankpin and the shaft or between adjacent crankpins called also crank arm, and it is also called as crank arm or crank throw. Crank journals. In a reciprocating engine, the crank pins also known as cranker journals and or the journals of the big end bearings at the end of the connecting rod opposite to the piston. If the engine has a crankshaft, then the crank pins are the journals of the off-center bearings of the crankshaft. In a beam engine, the single crank pin is mounted on the flywheel. In a steam locomotive, the crank pins are mounted directly on the driving wheels. Next, main bearings. In a piston engine, the main bearings are the bearing on which the crankshaft rotates, usually plain or journal bearings. The bearings hold the crankshaft in place and prevent the forces created by the piston and transmitted to the crankshaft by the connecting rod from dislodging the crankshaft instead of forcing the crank to convert the reciprocating movement into rotation. These are the main bearings which we are developed in the IC engines. The main bearings. This is the piston, Cation pin, connecting rod, crank pin. This is the crankshaft, little end of bearing, and the skirt, top ring, and also the bottom ring. This is the overhanging crankshaft. Overhanging crankshaft is subjected to bending stress, direct compressive stress, and also the shear stress. Bending stress due to tangential force, bending stress due to radial force, compressive stress. While designing an overhanging crankshaft, the following two steps are considered when the crank is at dead center and when the crank is at an angle twisting moment. Okay, this is the side crankshaft and also the center crankshaft. Design procedure of crankshaft is nothing but the procedure adopted for designing a crankshaft is as follows. First one, initially the magnitude of various loads on crankshaft should be determined. The distance between the supports and their position with respect to the load is determined. For safety and simplicity purpose, consider the shaft to be supported at the centers of the bearings. At the centers of the bearings, assume the thickness of the web to be 0.4 ds to 0.6 ds, where ds is nothing but the shaft diameter, 0.22 d to 0.32 d, where d is nothing but the bore of the cylinder. Calculate the distances between the supports. Finally, determine the main dimensions of the crankshaft by assuming the allowable bending and shear stresses. Next, crank and crank arm. A simple form of crank is shown in the figure. It consists of an arm enlarged into a box at each end. The larger is pressed onto the shaft and small holds to the pin which is pressed into place and riveted or fastened by a nut. The empirical proportions are given in figure in terms of the diameter of the shaft and diameter of the crank pin. Where P is nothing but a maximum force on crank pin, P allowable bearing pressure, length of the crank pin and diameter of the crank pin. Now this is the crankshaft where it can be directly injected into this crank pin. The ratio L by D varies from 0.8 to 0.1. The bending moment turns the pin for an evenly distributed load and P becomes PL by 2. Means the half of the portion of the crankshaft will be generated to an IC engine. But actually the pressure, the movement of not evenly distributed. The bending moment may be as high as P into L. A mean value of P into 3 by 4 L may be assumed to be 0.75 D to 0.4 ds. The crank arm should also be checked for strength by considering it on cantilever beam. This is the crankshaft where the twisting moment angle will be generated with the help of the different types of angles in the twisting moment. F is nothing but F naught sin alpha plus theta, as gamma is equal to 90 degrees minus alpha minus theta. F is equal to F naught cos alpha plus theta. In the red, in the dead center position, Fr is maximum and is equal to F naught. Okay, when crank arm and crankpin rod are at right angles, F is maximum and equal to Fe and Fr is equal to the zero positions. And also if the force Fe is slightly varying, then the force acting on the pin in any position is same, but the force of the arm is very different of the positions. Next, different stresses induced in the crank pin. The different stresses induced in the crank pin are bending stress and torsional stress. Bending stress is nothing but I is equal to m by z. Okay, then like that, the bending stress at any section is given as sigma b is equal to mb into y by I, where mb is nothing but applied bending moment, I moment of inertia of the cross section about neutral axis. When the beam is subjected to bending moment, then the distribution of stresses can be analyzed by bending a thick leather belt. The bending stress induced in compressive in plane. Therefore, the outer fiber is in tension and inner fiber is in compression. Thus, the bending stress is maximum at the farthest fiber from the neutral axis. Torsional shear stress. Torsional shear stress is nothing but the stress induced under torsion is called torsional shear stress. A torsion is used to occur when a machine member is subjected to equal and opposite couples acting in parallel planes. When a shaft is subjected to torque T, then the shear stress induced will be the magnitude varying from 0 at the center to maximum at the outer surface of the shaft. Therefore, the shear stress at the outer surface is called it as tau max. Tau max is equal to 16T by pi d cube. If you are taking the shaft, the inner and outer diameter is also applicable. That's why tau max is equal to 16T into d naught by pi d to the power d naught power 4 minus d to 2. D naught is nothing but outer diameter of the shaft, Ti inner diameter of the shaft, T torque applied by the shaft. This is the different stresses induced in the crank pin, which is developed in the bending stress and also the torsional stress of the different allegations of the crankshaft. Okay, in this crank pin also there are different types of instant moments or stresses involved in the crankshaft. This is the shaft which is developed in this crank, and also the counterweight. Counterweight is nothing but where the main general bearings is called as counterweight with the help of the shaft bearings. And also the main bearing generals will be developed into these angles, and the flywheel mounted on the flange depending upon the different positions of the pistons. Okay, in this piston and also the crankshaft will be developed throughout the engine materials of the different angles. Mount and also the crank nose for pulley under vibration of the damper mounting, the mount for camshaft driving sprocket, the main channel oil weight, the lubricant, crank pin journal, counterweight, and crank pin journals, crank pin oil holes, main journals, and also the flywheel mounted on the shaft. And this is the same plane and this is the cross plane, which are the types of the crankshaft will be injected throughout the piston. This is the main part of the IC engine. This part is called as a piston. Piston is connected to the connecting rod. Connecting rod is connected to the crankshaft, and in this crankshaft only top rings, bottom rings, and skirt, little end bearings, gudgeon pin, and also the connecting rod, crank pins, and different pins also to be available.